Oh, this is taking me forever. I don't understand. Is it working? Is it working? Right, I think it's live. I don't have a preview though. I think I've made it work. I'm hoping I've made it work. Okay. Cool. Right, we're good to go. Okay, so what we're going to do is we're just going to go through two papers, I think. Unless I hear like a massive cry for lots of grade 9 questions, then I'll just chuck as many of those as I can at you. That was really stressful though, getting this started. I do not know why it wouldn't work. It just kept rolling around going, say, go live, go live, go live. And it just wouldn't go live. But anyway, we're here now. Fine, let's do it. Let's do some maths. So we've got question 1. This is of June 23. This is paper 2HR. If you have done 2HR papers before, great. They are just the same really as your regular papers. I will though, just quickly before we start a poll, and I'm just going to call it options, and the options are whole paper or just grade 9. What do you want to see tonight? Have I sent that off? Yes, I think I've sent that off. Okay, cool. So we'll see how that gets on. And I'll start with this nice and easy question just to warm us up. So we've got -5, I like to put it in brackets, square it, take away 4 lots of 3. Okay, cool. So that will be 25 minus 12, which will give us 13. Bosh. Next, we're going to multiply out these brackets. I like to use the claw method like this. We're going to get an x squared, we're going to get minus 7x, we're going to get plus 5x, and we're going to get minus 35. This is going to give us x squared minus 2x minus 35. And I'm going to write my answer on the answer line, and there is a nice 4 marks. Bosh. Okay, fantastic. Right, cool. Got some votes here. 79 votes. Most people want in grade 9 questions. Okay, that sounds good. All of my tabs all in the wrong place at the moment, so I need to sort myself out after that faff of getting this to working. Okay, right, let's just carry on with this and then we'll move on to maybe some harder questions in a moment. Okay, so he wants to buy a pack of pens and some boxes of pencils for his stationery shop. Each packet of pens contains 9 pens and each box of pencils contains 12 pencils. The pens cost that, the pencils cost that. He can only buy 4 packets of pens and pencils. He wants to buy exactly the same number of pens and pencils, work out the minimum he can spend. Okay, well we're looking for the lowest common multiple of 9 and 12. And the easiest way to do that is just go through the multiples really. So 9 up looks like that, and the multiples of 12 look like this, and then bingo, bango, bongo, you've got yourself the lowest common multiple there. So that means that we need to buy 4 packs of pens, because 4 times 9 is 36. So 4 packs of pens cost this, and we're going to have to buy 3 packs of pencils to make 36. So we go to our calculator and we do 4 times 7.6 plus 3 times 4.8, and we get a total of £44.80. Okay, right, let me just move my things around. How could I had it when I started this? Okay. Hi sir, can we do June 2024? I'm not allowed to do June 2024. Can only do papers that are a year old. Lots of people saying grade 9 questions. Okay, nice. Well, I'll tell you what we'll do is we'll skip some of the easier ones. And maybe what we'll do is we'll start right here, because this is actually a very interesting question that I think I've done this before. Okay, so have a little look at that question. I'll give you a moment and then I'll start going through it. Yeah, it's not about whether or not I have the paper. I have access to the paper. I did the paper as soon as the students did. It's just that I'm not allowed to post papers that are under a year old. This paper is June 2023 2HR. Okay, and this is question number 9, and it says that we've got a rectangular sheet. Oh, thank you very much for supporting Mr. Asprey. Appreciate that. Rayanne. So it says, all the information is on the diagram basically, and he says that this guy is going to join sides A and D, AD and BC together to form a cylinder. So therefore BC will be the height of the cylinder. This is how high the cylinder will be. You can think of this rectangular sheet as like the label on a tin of beans, for example. And it says that DC is going to be the circumference of that cylinder. Very good. Okay, so that's the circumference. It says work out the volume of the cylinder. Give your answer to 3 significant figures. Okay, so we're going to use some trigonometry here to work out the side length BC. So BC is the opposite, and we have the hypotenuse like that. So what we could do is we could say that sine of 32 is equal to the opposite, which is BC, over the hypotenuse, which is 50. So this means that BC is equal to 50 multiplied by sine 32. So we can get our calculator out, and we could do 50 sine 32, and we get 291.4. Beautiful. Okay, so that's the height, but we also need the we're going to need the radius of the cylinder in order for us to work out the volume. So we have the height like this. So the next thing I'm going to do is I'm going to work out the adjacent. Now you could use trig again, or you could just use Pythagoras' theorem. I think I'm going to use, let's use Pythagoras' theorem. So 50 squared minus the other short side squared, and then square rooted. That is going to give us DC. Okay. Whoops, I made a mistake, didn't I? Oh, my calculator, you donut. Okay, so we know that wouldn't be correct because, of course, the short side cannot be longer than the hypotenuse. That's why I paused there, because I knew I made a mistake. Okay, so we've got 8, we've got this here like this. Yes, let's square that, perfect. Okay, so we're going to do the square root of 50 squared minus 26.5 squared, and that's going to give us 42.4. Okay, so that is the circumference of the cylinder. That's wrapped all the way around the cylinder like that. So in order for us to find the radius, which we're going to need, we're going to have to take the circumference and set it equal to 2 pi r, because that is the formula for the circumference. So if I divide this through by 2 pi, I'm going to get the radius. So I'm just going to go on my calculator, divide by 2 pi like this, and that's going to give me 6.74. Okay. Right. Once we've got that, we could then work out the volume by doing the pi r squared times by height, times by the height. And we know the height is BC, which is 26.5. Okay, lovely. So what I'm going to do is I'm going to square that, I'm going to times it by pi, and I'm going to times it by 26.5. Okay, and I get 3790 to 3 significant figures. Perfect. Okay, right, I thought that was a really good question because you've got to understand that that rectangle is going to wrap around to make a cylinder. You've got to use a bit of trig, a bit of Pythag, and you've also got to work out, work backwards to work out the radius. Thank you so much, Adil, for that support. Appreciate that. Okay, right, let's keep cracking on. That was a 6 marker as well, actually. Okay, so next one. It says this person works as a taxi driver. Last week he recorded the following information about distances he drove. For the 5 days from Monday to Friday, the mean kilometers was 104, and for the 7 days from Monday to Sunday, the mean kilometers was 127. On Saturday, they drove 132. Work out the total numbers of kilometers driven on Sunday. Okay. So what we're going to do is we're going to take this information and we're going to work out how much they drove in the first 5 days. So from Monday to Friday, the amount they drove would be the number of days multiplied by the mean, which will give me 520. And we could do the same as well from Monday to Sunday. We could work out that on if they on average for 7 days drove 127, then we do 7 multiplied by 127. I'm not going to do that one in my head. What we're going to get here, we're going to get 889. 889. Okay, so the 2 days difference is the difference between how much they drove from Monday to Sunday and how much they drove from Monday to Friday. So if I subtract here 520, that gives me 369, and we know also that they drove this much on Saturday, so if I take that away, then that will be how much they've left over and driven on the final day. So 237 is the final answer there. Okay, nice one. Okay. Why did we use the circumference formula in the last question? We did that in order to work out the radius, because we knew that the circumference was the same as this distance here on the rectangular sheet. Okay, maybe now we should move into the more grade 9 area. So what I'm going to do is we're going to skip on a few more. This one's a good one actually, because how do you work out the compound interest rate if you're not given it? This is quite a tricky part. And yes, sir, can we do harder questions? Yes. We'll get to that. Don't worry, we'll get to some harder questions. So have a think about this. We invest this amount of money for 4 years at an unknown compound interest rate, and at the end of it, we know how much we've got. So let's call the interest rate, let's call it Y, And we know that we're going to be cubing that because it's compound interest, we're doing it for 3 years. And that's going to equal 6151.25. Oh, but that's just the total interest though. So if that's the total interest, then that means that in fact the amount of money that will be in the account, you need to add on the original 80,000. Okay, so if I divide through by this, I could do 86151.25, and I could divide it by the 80,000. This gives me 1.07689. Okay, now I've been careful not to use x yet because it says an x%. That's not the actual multiplier. So we can find the multiplier y for each year by taking the cube root of this. And then afterwards we'll have to look at what this is and figure out what the actual interest rate is. So I could do the cube root like this on my calculator of the answer, and we get a lovely number here, 1.025. That fills me with lots of confidence. So what is x? What is x? That's how much we're multiplying by each year. So what is the percentage rate? What is that percentage? Looking in the chat. Come on, who's going to get that for me? What's the percentage? So can we do the 2025 paper? Don't know what's going to be on that one, I'm afraid. Okay, well, I've not got anyone giving me the right answer here. Yes, there it is, Arjun, 2.5. It's a 2.5% increase, looks like this as a multiplier. That's what the multiplier is of a 2.5% increase. So x is 2.5. Nice. Sir, do you have the 2024 November paper? Of course not. All right, let's keep going. Osvaldo has a bias coin. The probability that the coin lands on heads 3 times is given as this. So heads, heads, heads. That equals 27 over 64. How do you do the probability of getting heads 3 times in a row? And what you need to do is you need to multiply the probability of getting a head times by it happening again times by it happening again. That's the only way we could get 3 heads in a row like this. So in fact, it's the probability of getting a single head to the power 3 is going to equal 27 over 64, like so. So to find the probability of getting a single head, we're going to have to take the cube root of 27 over 64. And I can see this is nice numbers because the cube root of 27 is 3 and the cube root of 64 is 8. Okay, great. So that's the probability of getting a head. Then the probability of getting a tail is, of course, 1 minus that. It's the complement of it, which is 5 over 8. So how do we work out the probability that the coin will land on a tail 3 times? Well, it will be the probability of it landing on a tail times the probability of it landing on a tail times the probability of it landing on a tail, which is 5 over 8 to the power of 3, which is 125 over, I should know this, 512. Bosh. Oh no. Oh, you donut. You absolute donut. This is why you use a calculator in your exam and you don't rush. That is a 4. Because the cube root of 64 is 4, not 8. That is a 4. So therefore, this is now 1 over 4. And 1 over 4 to the power of 3 is 1 over 64. Ah, sir, I'm washed, exactly. Yes, that is the correct term. Washed. Okay. Don't rush, take your time, we could be here all day. Yeah, exactly. Okay, so what we're going to do is we're just going to finish the paper from here because these are good questions, and this is the kind of area of the paper which is really going to boost your grading. If you get these questions right, you're onto a good one. The first half of the paper is relatively straightforward. Do not take your time. Okay, well, one of my most favourite videos I've ever made was the one where I tried to speed run a IGCSE paper. That was so much fun. Okay, what are we doing here? Well, to rationalise the denominator of a fraction that has a surd part and a rational part to it, you must multiply top and bottom by that same surd and that same rational, but with the sign changed. So that is how you rationalise the denominator of a surd that looks like this. Okay, now to make it easier for myself, I just like to put it into brackets like this. I find it easier to see what's going on, and I don't want to miss anything. So first thing, 2 root 3 times root 3. So that is going to be 2 times 3, because root 3 times root 3 is 3. So 2 times 3 is 6. Okay, and then plus 1 times 2 root 3 is just 2 root 3. Someone's asked me, am I going to do that another session on Zoom for paper 2? I'm not sure, to be honest. I didn't have too many people thumbs up the comment, so I might give that a miss, but maybe. Okay, so root 3 times root 3 is 3, and then we're going to have root 3 times 1 is root 3. And then we're going to have minus 1 times root 3 is minus root 3. And then we're going to have minus 1 times 1. It's just minus 1. Okay, that is going to give me 6 plus 2 root 3 all over 3 minus 1, because these will cancel, and that gives me 2. Divide through by 2 gives me 3 plus root 3. And I think we're done. Bosh. Okay. Lovely. Okay, let me do a poll then. End that poll. How's my pace? Pace. Is it too fast? Is it just right? Or is it hurry up, bruv? Okay, there we go. Am I going too fast? Is it just right? Or do I need to hurry up? Okay, next question. Let's cube both sides. 6 plus 5x over x plus 4. That gets rid of the cube root. multiply through by x plus 4. Okay, I can see most people are saying, hurry up, bruv. Better speed up then. 4y cubed is equal to 6 plus 5x. And now, critical point, we've got to move all of the terms that have an x in to one side, and all of the terms that don't have an x in to the other side. So I'm going to minus 5x, and I'm going to minus 4y cubed, like so. Okay, let's take out a factor of x, and then that allows us to divide through by that factor. So we have 6 minus 4 y cubed all over y cubed minus 5. Okay, right, bosh, let's go. How's that poll coming along? Yeah, most people say I need to go faster. Fair enough. Aha, right. We have the Chord theorem, and it asks us to work out DC, which I'm going to label X. Now, so many people make a mistake on this question. The most important thing to do is make sure you draw all of your lines, or all of the values that you use must always come from the intersection point, which is P. So I'm going to do P to B multiplied by A to B, because they're on the same chord. So it's this one, and it's that one. So that will be 14 multiplied by 16. And now that's equal to the same thing on the other side, which is C to P multiplied by D to P. So that will be 12 multiplied by 12 plus x. So again, it's so important that you make sure that all the distances you use are from P. So that's 12, and a lot of people just times that by x, but it's not. It's the distance from P, which is x plus 12, like so. Okay, right, 14 times 16. I really should know that. 224. And that's equal to 12 times 12 plus x. So we're going to divide that to... we're going to divide that... Oh my god. Literally just said what not to do, and then I've just gone and done it. It's not 16, it's 30. It's 30 in there. Oh, so embarrassing. Apologies for these mistakes. A bit nervous under the lights, it looks like. 12 times 30 is 420. Thank you. Who spotted that first? Fred. Thank you very much, Fred. And that's 12 multiplied by 12 plus x. So we're going to divide that by 12. We're going to get 35. So that's going to give me x is equal to 23. Yes, let's go. Okay, still in the game. Still in the game. Okay, we're getting into the harder questions now. Question 19. We have got 30 adults staying in a hotel. You've got 19 that booked breakfast, 15 booked dinner, 4 did not book breakfast or dinner. Some adults booked breakfast and dinner. What's the probability that you pick 2 people that did breakfast and dinner? Okay. Okay. We're going to do more difficult questions for sure. I'm going to finish this paper off. Okay, so I'm going to do a Venn diagram here. I'm going to have breakfast, and we're going to have dinner. And it means there's going to be 4 people outside. Now, there's a really special formula, which is if you, in this case, add up the sets of B and D, then you'll need to take away the intersection of B and D, and that will give you the union of B and D. So in this case, I know the union of B and D is 26 because I know there are 30 adults and 4 of them are not in the Venn diagram at all. They're not in the circles. They're not in the union. So I know the union is 26. The number of people in B are 19 and the number of people in D are 15. So this allows me to work out the bit in the middle, because I have 26 is equal to 34 minus the bit in the middle. So therefore, just rearranging that, it's going to give me the bit in the middle is equal to 8. So if I know 8 goes in here, I then know that there must be 11 in here to make 19 in total for breakfast, and there must have been 7 in here, and that's all going to add up to 30. Now, I picked 2 people, and what's the chance they are in the middle, in the intersection? Well, the first person, it will be 8 out of 30. And then the next person, there will be 7 out of 29. Because of course you've already selected one person. So therefore you have to drop the number down. So it's 8 out of 30 multiplied by 7 out of 29. And that gives me 28 out of 435. Okay. Right. Yeah, the stream I'm gonna do for 2 hours. Yeah, we're just going to get on to the harder questions now. And I know people are crying out for grade 9 questions, so what we'll do is we'll do the rest of this paper, and then the second paper I will start from the back end and go the other way. Okay, so we've got ABC. It says find the angle of ABC. Well, as you know, you draw a line from A, then to B, and then to C, and it's the angle that creates will be the angle ABC. So it's this angle that we're looking for up here. And by alternate segment theorem, if we have a tangent which hits a triangle which is inside the circle, then the angle here between the tangent and the triangle is the same as the angle up here. So this is alternate segment theorem. Now we also know that because this is an isosceles triangle, this angle in here is also going to be 78. So the angle we're looking for is 180 minus 78 minus 78. So I do 180 minus 78 minus 78. Okay, which gives me 24. Yeah, I think you'll be able to see the stream afterwards. This is paper 2HR from June 2023. Okay. Right, next one. Right, I'm picking up the pace and I'm doing harder questions. So hopefully that is what everyone wants. Work out the coordinates of the points of intersection. Okay, so this is a quadratic simultaneous equation. So I'm going to take the linear equation, which is this one, and I'm going to make x or y the subject. But it's easier here to make y the subject. I just need to add 2x to both sides, like so. Okay, so next you just substitute into the second equation. So I'm going to sub into this equation. So I'm going to replace all the y's with 2x plus 1. I don't do predictions for paper 1 because no one can. Who knows what's going to be on paper 1? What I have done in the past is predictions for paper 2, because for paper 2, you know what's happened in paper 1. So you can eliminate those topics that are unlikely to come up twice, and you can pick the topics which have not come up yet. Okay, so we should get that. That looks all good to me. Don't think I've made any mistakes. I think that's all good. Okay, so that gives me 4x squared plus 2x plus 2x plus 1 when I expand out that double bracket. And then I'm going to get 2x squared plus x as well, and that's equal to 7. Okay, so that's going to give me 6x squared plus 5x, and then plus 1 equals 7. And then what I'm going to do is I'm going to move it all over to one side like so. So I should get that. Okay, so that looks all pretty good. And now what I need to do is I'm going to need to factorise that. And I'm going to teach you my super quick way of factorising tricky quadratics like that. Not going to make predictions for the paper. I don't know what's going to come up. No one does. It could be anything. And I might do predictions for paper 2 if I've got time and there's lots of demand for it. Okay, but also the problem is that I won't see this paper like I do the normal papers in the summer, because there's no one at the school I work at that's actually doing the paper, so I won't really be able to make predictions for paper 2, to be honest. Right, AC is 6 multiplied by minus 6, and B is equal to 5. Also, there's not a lot of time between the papers, is there? It's like literally 48 hours. Okay, so what we do is we write, because this is, the A term is 6, we write in both brackets 6x, and we divide the whole thing by 6. And then we need to find two numbers that times to make minus 36 and add to make 5. So those would be positive 9 and negative 4. They do the job. Okay, now how do we divide these two brackets by 6? We can't divide either of the brackets directly by 6. So instead what we're going to do is we're going to divide one of them by 3 and one of them by 2. That will do the job. So I divide the first one by 3 and the second one by 2. And that perfectly divides everything by 6, and that is the factorised form. Okay, so this gives me x is equal to minus 3 over 2, and it gives me x is equal to 2 over 3. And then the final thing to do is to check your other equation to find what the y values are. So you need to double the x values and plus 1. So if I double that, it gives me minus 3, and if I plus 1, it gives me minus 2. If I double that, I get 4 over 3, and if I plus 1, I get 7 over 3. Okay, and that is another question down. Seems pretty good to me. Is there a formula for 3 sets similar to the formula for 2 sets for the union and intersection? No, I do not believe there is a formula for that. Sir, you need to speed up. Okay, thank you. Work out the length of BE. Okay, perfect. That is the long diagonal. And I've got a formula for this. To find the long diagonal of a cuboid, you just take all 3 dimensions and you square them and you add them together and then you square root. So 15 squared plus 4 squared plus 9 squared. That's simple. That's how you find the that's how you find the long diagonal. And that gives me this. Okay, and it asks me the 3 significant figures. So that is 17.9. 17.9. Perfect. Okay, so that's a useful formula to know. To find the long diagonal inside a cuboid, you just square all of the dimensions, add them together, square root. Okay, we've got a 3D trig question this looks like. So we've got an angle here, so we're not going to be using Pythag. And it says that PR is 42, so I'll draw that on straight away. PR is 42. Okay, so that's 42 there. Brilliant. And it says that the size of the angle PU and the plane is 30 degrees. So that angle in there is 30. If I draw a line straight down, I've got myself a right angle triangle. Okay, and it says M is the midpoint of PR. So M is here, which means that this side is 21. So this is the midpoint. And it says find the angle UMR. So U comes down to M and then goes along to R like that. Okay, interesting. So if I draw the green triangle out separately, which I always recommend you do on 3D trig questions, all I've got so far is that it's 21 there. So I need more information if I'm going to work out what this angle in here is. So I'm going to have to use the blue triangle, and I'm going to have to think about, do they share any sides? Well, yes, they do. They do share this side, UR. UR, UR. So can I work out UR from using the blue triangle and then transfer it to the green triangle? Okay. What is this side over here? Let's call it Y, or let's just call it UR in fact. Well, if I used a trigonometry, then this says that tan of 30 degrees is the opposite, which is UR, over the adjacent. So UR is therefore equal to 42 times by tan of 30. Okay, great. I can just leave it like that. I don't need to necessarily work out exactly what the value is, because I'm just going to put it straight back into my calculator. So using the green triangle, tan of the angle I'm trying to find is equal to the opposite, which is this, over the adjacent, which is that. So on my calculator, I just need to do inverse tan of this, and that's going to give me the exact angle. Okay, is this higher or foundation? Okay, 42 tan 30 over 21, I believe. And we get an answer of 49.1 degrees. Okay, right, let me just check the chat if there's anything useful. Please, sir, best teacher ever. Thank you very much. That is very kind of you. Sir, speed up, trig graphs. Sir, where are you from? London. Sir, you find differentiation hard. Yeah, it can be. Okay. So when you're factorising in your way and it isn't divisible by 6, for example, you divide by 2 and 3 because they multiply to make 6. That is correct. Yes. It will, if it does factorise, it will always be able to divide through by that number. Okay, here we go. Right, sequences question here. So you've got 3 terms in this sequence. So this is number 23 question. Is this going to be uploaded? Yes, this will be uploaded. It'll just go straight onto YouTube, I'm sure. This is only my 3rd ever live stream, but all the other 2 are on my channel for people just to watch whenever they want. Okay, so what have we got here? We've got 3 terms, and in fact, it's the first 3 terms. So I know that A is the first term, is 8p. Now, how do I find the difference between 2 terms? Well, what you do is you take the larger one and you subtract the smaller one. that's going to be the difference. So I'll do 7p minus 3, and then minus 8p. So that simplifies down to minus p minus 3. Okay, so that's the difference. But that doesn't help me too much. What I can do now is I can work out also the difference is also equal to this one minus this one. Because of course the difference is always constant between the terms. So I can find another expression for the difference. So I could do 4p plus 2 and then subtract, and I'll just put it in brackets so I don't make a mistake, 7p minus 3. Okay, so this gives me minus 3p, because 4p minus 7p is minus 3, and then 2 minus minus 3 is plus 5. Perfect. So now what do I do? What do I do next? I've got two expressions for the same difference. Well, I set them equal to each other. I add 3p to both sides, and I add 3 to both sides. So I get p is equal to 4. Perfect. Now I know what the first term is, because it is 8 times p, so it's 32. So I know the first term, that's useful. I also know what the common difference is. I could put it into either one of these formulas. But if p is 4, then minus 4 minus 3 is minus 7. So I know what the common difference is. Brilliant. And then it says that the sum of the first n terms of the sequence is given as this number here. So the formula, which you're given in your sheet at the front, is n over 2, 2a plus n minus 1 d. That's the formula for the sum up to n terms, which is exactly what we're doing. We're summing up to n terms. And we're told that that's equal to minus 19, 14. Okay, so what I can do is I can times both sides by 2. I could do that straight away. That will just make things a bit easier. And I can also input a and d, because I know what they are now. So a is 32, so 2 times 32 is 64, plus n minus 1, and d is minus 7, like so. Okay. So next we can multiply out this bracket. We're going to get 64n. We're going to get minus 7n squared, because we're doing n times minus 7. And we're also doing n times minus 1 times minus 7, which will be plus 7n. Okay. So this is going to give me minus 7n squared plus 71n is equal to minus 3828. I'm going to bring it all over to the other side, so we've got positive n squared, and we're going to have this, like so. Okay, now you need to make sure that you use the quadratic formula and not just go into your calculator and solve this, but I'm a bit lazy and people have been screaming at me to hurry up, so I'm not going to bother going through the quadratic formula. But you would need to show you're working on a question like this. We get 29 and we get a negative number, so that's never going to be the answer for the number of terms. So we get 29, so n is equal to 29. Okay. Lovely. Why does sequences have 3 different methods? Not quite sure what you mean by that, but what you need to know for sequences is you need to know that any given term is equal to the first term plus n minus 1 terms multiplied by the difference. And you also need to be able to use the summation formula as well. Okay. Right. Cool. Keep on going. Question 24. Why can't you take minus... You can take it to the other side to make it positive. It just means you have a negative n squared, but it'll still solve exactly the same. So it doesn't matter which side you set equal to 0. It will solve exactly the same. How did you get minus 71n? Well, I got minus 71n. I got 64n from doing n times 64. And then I got 7n by... It's because when I multiplied this bit out inside here, I would have got minus 7n plus 7. How did I... Did I make a mistake there? No, I got that. That was right. Yeah, I think that's right. I think I got that right. Okay. Right, okay, let's do the next question then. It says that the surface area of the sphere A is 9 times the surface area of sphere B. Okay, so whenever you see a question like this and it's looking at the surface area and it's looking at the surface area and it's also looking at the volume of an object, you know you're going to need to use the scale factors and switch them up between the between the different ones. So you've got k squared, that is the surface area, what's the word? It's the surface area scale factor. Oh, I've just seen the ginger mathematician is in the chat. Hello, yes. I love your channel, very good. Right, so we've got k squared is equal to 9 because the sphere's surface area is 9 times bigger. And the surface area scale factor is always the linear scale factor squared. So that means that the linear scale factor is going to be 3. And it means that the volume scale factor is going to be 3 cubed, which is 27. Okay, great. So now it means we can convert between the volumes. So the volume of A is equal to, it's the bigger one, right? Is A the bigger one? Yeah, A is the bigger one. So it's equal to 27 times the volume of B, like so. Okay, so if the volume of A is 27 times the volume of B, it means you could say the volume of A is 27 VB. And if we're looking at the difference between the two volumes, if volume A is this, then the difference I will need to subtract volume B, and that should give me the difference. So the difference will be 26 VB, and that is equal to 117 pi. Okay, so again, the volume of A we know is 27 times the volume of B, so the difference between them is 26 times the volume of B. So we could divide through and that gives me like this. We can do that on our calculator, and I'll do 117 pi over 26, and we get 9 over 2 pi. Okay, so if that's the volume of the B, which is the smaller one, and we do need to find the radius of the smaller sphere, then we could just set the volume equal to the formula for the volume, which is 4/3 pi r cubed. Okay, first things first, we could divide through by pi on both sides. We don't need that. And then we could take this 9 over 2, and we can multiply both sides by 3, and then divide both sides by 4. So this gives me 27 over 8 is equal to r cubed. And then from there we can take the cube root of both sides, which is going to give me 3 over 2. So that's the radius of the small one. Okay, let's see if there's any comments, anyone asking any questions, or was that all good? That was, yeah, this is 2023 to HR. And that was quite a tricky one, really. I think the tough part there was realizing that it's going to be 26 times the volume of VB is the difference. Okay. Let's do this question here then. Whoops. Okay. Is this the final question? Oh no, there's one more. There's a trig graph one after this one. Okay. This is a toughie, for sure. In fact, I've done this one recently. Okay. So people are asking, why is it 27 VB minus VB? It's because they give you not the volume of A, but the difference between the two volumes. And if we know the volume of A is 27 VB, and we know the volume of B is VB, then the difference between them is 26 VB. Okay. What have we got here? We've got the straight. This question is really tough. This is a really tough question. Why are we doing paper 2? We have paper 1 in 2 days. The papers are completely, there's no difference between them. It's not like paper 1 topics only come up on paper 1. Any topic can come up on any paper. Okay. So let's have a look now at this. We've got a straight line, and we're told that it is y minus 2x equals 7, which I'll just write this way round, 2x plus 7, because that's how we normally see it. Okay, and then we know that that line there is the perpendicular bisector of the line AB. So let's say this is just AB then. That's A there, and that's B. And if it's the perpendicular bisector, that's a right angle. And these two sides are the same length. Okay, so we know A is J7, and we know that B is 6K. Okay. I don't think HRs are harder than H's. Perhaps they're slightly harder, but I don't think there's too much difference. Find the coordinates of the midpoint of the line AB. Right. So what do we know? We know the gradient of the blue line, don't we? We know the gradient of the blue line is 2, which means the gradient of the green line is minus a half, because it's the negative reciprocal, because it is perpendicular. So we know the gradient of the green line. Okay, great. Well, it means we can form an equation then, because we could work out the gradient of the green line by doing the formula that the gradient is equal to y2 minus y1 over x2 minus x1. So we could do 7 minus k over j minus 6. And we know that that's equal to minus a half, because we've said that the gradient of the green line is equal to minus a half. Okay. So that's my first equation, but that equation has two unknowns in it. So that means I'm going to need to find another equation in order to solve them simultaneously. Now what are we going to do? So we're going to, we can work out what the midpoint is actually. The midpoint M is equal to, well, it's the x coordinates halved after you've added them together. It's the average of the x coordinates, and it's the average of the y coordinates. So k plus 7 over 2. Okay, but that's not an equation, is it? And here comes the really tricky part. We know that that midpoint is on the line y is equal to 2x plus 7. We know it's on this line, the midpoint. And if a coordinate is on a line, it means it satisfies the equation of that line. So it means that if I take the y coordinate of the midpoint, it should equal 2 times the x coordinate plus 7, because it is on that line. So my second equation can look like this. Y, which we know is k plus 7 over 2 for that midpoint. The y coordinate of the midpoint can equal 2 times the x coordinate plus 7. And there we have another equation, because once again it is the y coordinate is equal to 2 times the x coordinate plus 7, because the midpoint is on that line. Okay, now we've just got to solve them. So the first thing I could do is we're timesing by 2 and dividing by 2 there. So I can simplify that. So this side of the equation becomes j plus 6 plus 7 is j plus 13. I can then multiply both sides by 2 to get 2j plus 26. And then I can subtract 7, so I get k is equal to 2j plus 19. Okay, so there we go. That is my second equation now. Okay, and now let's take this, this one over here, and let's simplify this up as well. So I can multiply both sides by 2, and that will give me 14 minus 2k is equal to minus 1. And then I can multiply both sides by j minus 6. And because I'm timesing it by minus 1, it's going to give me minus j plus 6. Okay. Now we've got to solve these simultaneously. So what I'm going to do, I think the easiest thing to do would be just to substitute in. It might not be the easiest way of doing it, but I'm just going to, because this one's already k equals, I'm just going to replace the k over here, like so. This gives me 14 minus 4j minus 38. And then I don't want to make a mistake now, so I'm just going to use my calculator. 14 minus 38 is minus 24. So we have minus 24 here. I'm going to add the 4j to that side to make 3j, and I've got plus 6 here. Perfect. So we can see here, this is going to give me j is equal to minus 10. So if j is minus 10, then k is minus 20 plus 19, which is minus 1. Perfect. Now they asked us for the midpoint, so all I need to do is just substitute into the midpoint formula we've already created. So if j is minus 10, then it's minus 10 plus 6 is minus 4 divided by 2 is going to give me that the midpoint is equal to, what's that? Minus 2. And then when I sub in k, it's going to give me 3. And that's my final answer. Okay. That was a really crazy question. Yeah, it's a really tough one. But hopefully I explained it quite well and it made sense. And it's not the first time I've seen that trick as well, where you have to, you have like a coordinate in algebraic, which you then need to sub into the line in order to work out. Okay, there's one more question I think, and then we'll do the grade 9 questions on the other paper as well. Okay, so this is a classic question, comes up all the time. And the way that I solve these is the first thing I do is I draw the line of symmetry. Not the line of symmetry, let's say, but like the line of perfect reflection onto the graph. Whoops, apologies. So that line is like that. Okay, and you can see here how the peaks and troughs are the same distance away from that line. Okay. Now, the reason why I've done that is because that really tells us how much the graph's been shifted up. Because the original cos graph has that line of symmetry along the x-axis. So it's clearly been shifted up by 1 unit. And to shift something up by 1 unit, you add on to the function. So therefore c is 1. So that's the first part. Okay, next we know that the cos graph oscillates between 1 and minus 1, like this. So that means it has a range of 2 units. Whereas this graph here goes from minus 1 to 3. So that has a range of 4 units. Whereas the original cos graph has only a range of 2 units. So it's been stretched by a factor of 2. So therefore the stretch is what you multiply the function by. So that a means it's 2, like that. Okay. And I think that is about it actually, because the next thing we need to do is to see, oh no, sorry, there's a b there. The b is how much it's been stretched or compressed along the x-axis. So the cosine graph would normally do one full oscillation like this every 360 degrees. But in fact, you can see here that it's going to do that full oscillation 3 times in the space of 360 degrees. So that means it's been compressed by a factor of 3. So that means that b is 3 because when you multiply by 3 inside of the function like that, it compresses it by a factor of 3. Okay, right, I hope that was helpful. I'm going to now go on and do the other paper, and I'm going to go and I'm going to start from the back end. So I'm going to go all the way down to the bottom, and we will do question 25 first. Hope that suits everyone. And then we'll just work our way up until 8 o'clock. Unless there's, again, some particular topics that we might want to do. I'm not sure. Okay. So what have we got here? We've got a triangle, and we have an angle, and we've got two sides that are known, and it says that the area is given as this. So we know that the area of a triangle formula is equal to a half AB sine C, where transforming graphs. Yeah, okay, I could try and find a transforming graphs question. Thanks for that. Okay, so yeah, so the area is equal to a half. A is one side which is adjacent to the angle, and B, which is another side which is adjacent to the angle, and we multiply that by sine of the angle, 30, like that. And we know what that area is equal to, because we've been told that it's equal to this. And that is a half. It's actually a quarter, because you've got a half here, and sine of 30 is a half. So a half times a half is a quarter. And then we're going to multiply out these brackets to get 4x squared. We'll get plus 2x and minus 2x, and we'll get minus 1. Okay, so this paper is 1HR, and it is from June 23. So we've got x squared plus x minus 3.75 is equal to x squared and then minus a quarter, because the 2x's inside will cancel out, and we've got to divide by a quarter. Okay, the x squareds cancel out, which is quite nice. So we get x is equal to, when I add that to that side, it becomes 3.5. Okay, but the question asked me to find the largest angle. So my first instincts would be to use the sine rule. But the angle I know does not have a side opposite that I know. So I can't use the sine rule yet. So what I'm going to have to do is I'm going to have to use the cosine rule to find that missing side. But let's first put the numbers in. So if x is 3.5, then this will be 6, and this will be 8. Why did I change the half to a quarter? Because sine of 30 is a half. So it's a half times a half, which gives us a quarter. This exam is 1HR, June 23. Okay. So now it's just algebra. Well, we have to find this missing side over here. Let's call it BC. So we do BC squared is equal to A squared, which we'll call 6, plus B squared, which is 8, minus 2 times 6 times 8 times cosine of 30. And from there, we can use our calculator to work out BC. So it'll be 6 squared plus 8 squared minus 2 times 6 times 8 times cosine of 30. And we get 4.10. Okay, great. You said this was 2HR. We did 2HR, we finished it, and then we've moved on to 1HR, and we're starting at the back of the paper, and we're going to work up. Okay, so we know we know what BC is now, so now we can use the sine rule. Because we can use the sine rule because we have an angle and we have an opposite side, so therefore we can use the sine rule. Okay, so what will I use? Let's use 6 and work out this angle over here. Okay, so let's call that angle, well, capital C, why not? It's already labelled that, so let's do that. Okay, let me just get rid of this working so we've got some space. And we're going to say that sine of capital C, because I'm trying to find the angle, I always put sine of the angle on the top, over the side which is opposite it, and that's equal to sine of the angle of the pair that we know over the side of the pair that we know. Okay, so I can reverse engineer this to get 6 times sine 30 over 4.10, and then I can find C by doing the inverse of sine. So I could do inverse sine, open brackets, 6 times sine 30, again I know sine 30 is a half, so I'm just going to speed it up by just typing that in, over 4.1. And I get 47.0. So if that's 47.0, then in fact it was this side, and this angle is the largest angle. So I can do that by doing 180 minus the two angles I know, which are 30 and 47. So I get 103. To the nearest degree is the answer. Beautiful. Do I think that the November paper is harder than June? I don't know. But last year's November paper was actually quite tricky. So perhaps it is. But it doesn't matter because you guys are going to boss it anyway. Could you find B by using the cosine rule? By using the sine rule? Yes, you can find B using the sine rule. It shouldn't give you a different answer. It should give you 103. If I was to do sine B over 8, it should equal sine of 30 over 4.10. That should definitely work fine. Can we practice the 2024 paper? No, I can't do 2024 papers. I have to wait a year until I can do those online. Okay, this looks like a harmless question, but it's actually really tricky, I think, because it's 5 marks. It's question 24, and the first thing we need to do is we need to spot that all of these are powers of 2, and so are these ones. These ones are also powers of 2. This is a new paper, yes. This is paper 1HR, June 23. The one we did before was paper 2HR, June 23. And from this one, we're going backwards. We're going backwards, starting with the hardest questions. Okay. Oh, some people are... Oh, right. Yes, sorry. This is important. I will go back on this. This is very important. It is giving you a different answer, isn't it? I bet you it's giving you 77. I bet you when you do this, you get, when you do sine to the minus 1 of 8 times sine 30 over 4.10, I bet you it gives you 77. Am I wrong? And that is because when you do the sine rule, there are 2 possible angles. It's really important. Sine has 2 angles under 180. So it will always give you the acute angle. But if the triangle has an obtuse angle in it, then you must do 180 minus the acute angle to get the actual correct obtuse angle. So very important to know that. Very important to know it. Okay? We got lucky in that C, you could tell C is actually acute just by looking at the diagram. And B is obviously the largest angle. We also know that B is the largest angle because it's opposite the longest side in the triangle, which is important to know as well. Because it's opposite the side which is 8. So the largest angle will always be opposite the longest side. Okay, well, hopefully that clears it up. Okay, so for this one, we need to write 2n is equal to 2x squared multiplied by 2 to the 4 is 16 to the x, multiplied by 2 to the 3 is 8. So this gives me 2x squared times 4x times 2 cubed. Now what do we do with any base which is the same? When you multiply them, you add the powers together. So it's x squared plus 4x plus 3. And now because both sides are 2 to the power of something, then those powers must be the same. So n must equal x squared plus 4x plus 3. Okay. But it says find an expression for x in terms of n. State any restrictions. Okay, two ways of doing this. Completing the square or quadratic formula. We need to make it x equals. Okay, so we need to find a way of making it x equals. So what I'm going to do is I'm going to set it equal to 0 like so. And then I'm going to use the quadratic formula. Or perhaps should I complete the square? No, well, I've done it now. We're going to do it complete quadratic formula. So, using the quadratic formula, what is the a term? Well, you can see here that there's 1x squared, so a is 1. The b term is 4. The c term is 3 minus n. Because the c term is the constants, the bits without the x. Okay, so the quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to here minus 4 plus or minus the square root of 4 squared is 16 minus 4 times 1, don't need to write that down, times by 3 minus n all over 2a, which is just 2. Okay, right, can we tidy this up? Well, inside the square root, you're going to have 16 minus 12 plus 4n. I'm going to multiply out that little bracket there, all over 2. Okay, minus 4 plus or minus the square root of 4, because that's 16 minus 12, plus 4n over 2. Right, now we're going to have to do a very sneaky trick to simplify this. Because what we could do is we could take out the square root of 4. And that will leave me just 1 plus n, like so. Okay. So that is going to give me minus 4 divided by 2 is just minus 2. Root 4 is 2. So dividing by 2 is just going to cancel that out. So it's just going to be plus or minus 1 plus n, like so. Okay. There we go. So, what next? Well, that is an expression for x like they've asked us for. but it says up here, x must be greater than 0, and it says we need to state any restrictions on n. Wowzer. So if x is greater than 0, then I don't think it's possible for this to be a negative. Because if that was a negative, then x would never be greater than 0. So we could get rid of that negative sign because x must be greater than 0. Now, if x was greater than 0, then what does that mean for the square root of 1 plus n? What does that mean for the square root of 1 plus n? Well, it means that that must be greater than 2. So it means 1 plus n must be greater than 4 by squaring both sides. So n must be greater than 3. So that's our final answer. X is equal to this with n greater than 3. Okay, it says n can't be minus 1. That's true, but I've also said that n is greater than 3, so that does the job. It means you're not gonna have a negative under the square root. Okay, you could do that question by completing the square, but I'm not going to do two methods to doing the same question. Okay, so now we've got 20 minutes left. We could do algebraic fractions. I could find a vectors question, histograms. Happy to take some requests. So can you once again say the sine rule, please? Okay, yeah, fine. I can do the sine rule. Now, if you have a triangle like this, okay, and in that triangle, you know one of the angles. And you also know one of the sides. Let's say, for example, this was 10. Then there are two different triangles that could be created. There's one that looks like this, and let's say, sorry, you know another side as well. Yeah, perfect. You know another side. Let's say the other side is 8. Then you could have one triangle that looked like this. Okay? And that would have a certain angle, like that. Or you could have, again, a 35 degree and a 10, but this time the 8 side looked like that. Okay, now these two triangles have the exact same information, but they have different green angles. This one is obtuse, this one is acute. Okay, so you've got exactly the same information, but you get two different answers. So that's very un-maths-like, I know, but the reason why is because the sine graph has two angles between 0 and 180 that have the same value. So this one is obviously the acute one, this one is the obtuse one. And the difference between them is that the obtuse one is 180 minus the acute one. Okay? There we go. That is it. That is the sine rule in a nutshell. You must be careful of it. There are two possible triangles created if you only have 3 bits of information. Okay, let's do this algebraic question. And then what we'll do is I'll find a vectors question where we have to use the lambda and mu. And then I think that'll probably be us done. Okay. So let's look at this. Algebraic fractions. Classic. First thing I'm going to do is that could be factorized, or sorry, it could be expanded to be x minus 2, x plus 2. Difference of 2 squares. I've done that straight away because I suspect we will need to cancel one of those factors. So I factorised basically. Factors are your friends. Certainly my friends. I don't have many others. Okay, now when we multiply, when we divide a fraction, it's the same as multiplying and flipping that second fraction over. And I'm going to, in the same step, I'm going to factorize this. How do I factorize that? I look at the AC, which is 4 for A and minus 2 for C. And this gives me minus 8. And B is equal to minus 7. Okay. Right, I'm seeing some people putting some requests in. I'll see what I can do. Okay. So now I do 4x, all divided by 4. This is how I factorize tricky quadratics. I'm looking for two numbers that times to make minus 8 and add to make plus minus 7. So that is minus 8 and plus 1. Okay, this is one of the examples where you could just divide 4 directly into one bracket. So let's do that. We get x minus 2 and we get 4x plus 1. Okay, and then there's also the minus 2x there, but because of BIDMAS, I'm going to be doing the multiplying first. Okay. Because we're multiplying, I can cancel this and I can cancel this because they're the same. One of them will be on the top and the other one is on the bottom, so therefore they're going to cancel. Okay, so I can now multiply the tops together to get x plus 2. And if you didn't understand that step, you can always just like turn it into a fraction by doing that over 1, and then hopefully it's easier to see which is on top and what's on bottom. Please do vectors. Kite question is tricky indeed. Okay, yes, kites and vectors. That kite 7 marker, I'm sure I've done that kite question before on my channel. 4x plus 1 minus 2x. Okay. Now here comes the technique called forcing a denominator. If I want to add a fraction to a non-fraction, I'm going to turn it into a fraction by forcing a denominator. By writing the denominator there and then multiplying the top line by that denominator. Okay. So what that has done is it's forced the non-fraction to have a denominator which is the same as the fraction, which means I can now add the two fractions together. So I just do the top plus the other top, and that is going to be all over the denominator like so. Okay, so that gives me x squared plus 2x minus 8x squared minus 2x when I expand out. Don't forget to multiply the negative to both terms inside the bracket. the 4 and the positive 1. And that's all over 4x plus 1, which gives me a total of minus 7x squared over 4x plus 1. Bosh. How many steps should you show while doing middle term? You want to show as much steps as possible, of course, but luckily this is a question which isn't a show that. So if you could get away with it. Okay, let's see, differentiation. Right, you want to do a vectors question, don't you, with those vectors stuff in. So let me see if I can find a vectors question. There's a kite question there as well. Where's that vectors question? I know I had one. Okay, must be in this paper. June, this is 23, paper 1H. Here we go, vectors. Classic. Okay. Hopefully everyone's happy with this. Let's go. Okay. So what do we know? We know that M is the midpoint of OA. Great. So that means that this up here is also A. Because if M is the midpoint, then it's the same vector which takes you from O to M as it is from M to A. Okay. We also know that ON is 1 part and NB is 5 parts. So if ON is B, then MB is 5B. So I can draw that on here. This part must be 5B. It's asking me to work out A to N. Well, how do I get from A to N? I go from here, down, and then across. That's how I'm going to get from A to N. So that's going against the direction of the A's, so it's minus 2A, and it's going with the direction of the B, so it's plus B. Okay, so what is next? Now it's asking me to find a vector method, the ratio AP to PN. Okay, so this is the tricky part. This is the part where you have to use the lambda and the muse. Okay, so what I'm going to do is I'm going to say that AP is a fraction of AN, and the fraction I'm going to call it is lambda. Okay, so A to N we already know, but A to P is definitely a fraction of A to N, and we're going to call it lambda. So we can say that A to P is equal to lambda multiplied by AN, which is minus 2A plus B. Okay, and then what you need is the vector cross, is what I like to call it. You need also to find a way of getting to P by using this line here. So I'm going to say that MB is equal to, well, how do I get from M to B? Well, I go minus A and then plus 6B, like that. So minus A plus 6B. Okay, so M to P, we're going to say that that is a fraction of M to B. Now that symbol I've just drawn is not an M, it's a mu. but that could be quite confusing, so I'm just going to use y instead. So MP is a fraction of MB. Great. So MP is equal to y multiplied by minus a plus 6b. But what I need is two expressions, one with a lambda, one with a y, for the same thing. So I'm going to find an expression for a to p using the red line. How am I going to get from a to p using the red line? I'm going to go down here, which is minus a, and then I'm going to go along MP, which is y minus a plus 6 lambda, like so. Okay, now we're set. We have the same vector, but expressed by two different paths, one for each of the coloured lines here, which create that cross with P in the middle. Okay, so I'm going to scroll down and get some more space. And I'm going to say that when I multiply them out, so minus 2 lambda A plus lambda B is equal to, that's the blue one, the red one as well, which is minus A minus YA plus 6YB. Okay. So now these questions are insane. You can compare coefficients. The A's on both sides must be the same because both of these sides are expressions for the same thing. So let's look at the A's. We have minus 2 lambda must equal, that's how many A's there are on the left, and on the right there's minus 1 and there's minus y. That's how many A's there are on the right. Okay. Now, by the same logic, the B's as well must be the same on the left and the right hand side. So on the right we have, so on the left we have lambda, and on the right we have 6y. And now it's just a case of solving these simultaneously. I'm going to rearrange this equation. I'm going to move the y to the other side, and I'm going to move the 2 lambda to the other side. And when I move them, they change sign, of course. And what I want to do is I actually want to find lambda. So I'm going to say lambda is equal to 6 lots of y, which from the other equation I've shown is 2 lambda minus 1. So lambda is equal to 12 lambda minus 6. So rearranging this is going to give me, I add the 6 to that side and I take away a lambda from both sides. So therefore lambda is equal to 11 over 6. And a lambda is exactly what I want because we are looking for the ratio of AP to PN. And remember, I said that AP was lambda times AN. So if this is 6/11ths of the whole line, it means the other part must be 5/11ths of the whole line, which means the ratio between the two parts must be 6 to 5. So the answer is 6 to 5. Okay. So I've done so many videos on this topic. Literally, there's like over an hour and a half. No, not that long. Maybe it's definitely over an hour on my series 1 and series 2 of these vector questions, and I use the same method every time. So, in summary, you need to create the cross. You then need to say that The fraction lambda is how much of AP is of AN. And you also need to show that the fraction y is how much of MP is of MB. You could then find an expression for the same vector. In this case I chose AP. And then you have to equate coefficients after you've done that. Okay. I might do one more question. How do I know if I'll do H or HR? If you're in, I mean, you just do the paper that's in front of you, basically. If you're doing this in November, then there's only H papers in November. There's not HR papers in November. Why did we add minus A in MP? Why did I add? I wanted to get an expression of AP. And AP, to get from A to P, I do minus A, and then I add on MP. So that's how I got an expression for A to P, like this. Okay. Haven't done any functions actually. Could do a functions question or differentiation question. We did a surds question, so I'm probably not going to do one of those again. Or a series question, we did one of those. Graph transformations, that question's insane. That one's quite difficult as well with the frustum. How do you do questions 16 from the same paper? What, Venn diagram? Is that what you're asking, Arjun? Kinematics doesn't come up very often, actually. But I'm happy to do a kinematics question. I have seen someone ask for that quite a few times. This one, the 16th question in this paper, please. Okay. A few people asking me to do this question. I'm on it right now. And the frustum. Sure, why not? Why not? If it's going to help you guys out, then yeah, sure, I'll do it. Okay, this one, the number in the union is 42. So the union of A and B is all of this, like so. So the number of terms is 42, and clearly I can see here that there is 9 plus 5 plus 3 plus 7 plus 12 plus x. Which is 14, 24, 36, so it's 36 plus x. So take 36 from both sides, so 6 equals x. Okay. Find not A. So how many objects are not in A? So you're not in A, you're not in A, you're not in A, and you're not in A. So that is 14 plus 22, which is 36. And then finally, not in B and in C. So who's not in B and is in C? Not in B and you're in C. You must be, no, oops, 5 and 10. Those are the ones that are not in B and in C, so that's 15. Okay, lovely. Okay, so let's do, lots of people are asking for kinematics. Now, I'm not sure where, I'll do. I'll do this question, just a random kinematics question. Because I don't have one that I lined up for today, I don't think. But anyway, kinematics is a topic in differentiation, which deals with displacement, velocity, and acceleration. So you do have to use differentiation to solve kinematic questions. The trick is that it's they either give you v equals, s equals, or x equals, or maybe a equals. So you have displacement, like so, and then what you'll need to do is you need to differentiate it, and that will give you the velocity. And if you differentiate that, that will give you the acceleration. Whoops, I'm not in shot, am I? Sorry. Apologies. Yeah, okay, there we go. So that gives you the acceleration. Okay. So this is, I don't even know where this question is from, to be honest. I've just found it in one of my notebooks, because a lot of people ask me for differentiation. Okay. So let's look at this question. I mean, straight away, I'm going to get myself some marks by just differentiating that expression. So because that is the displacement, if I differentiate it, I get the velocity. So I write v is equal to, when I differentiate, the 3 comes down times by the 4 to get 12, and we drop the power down by 1. And this is t to the 1, so times it by 27 gives you just 27, and then you drop the power down. T to the 0 is just 1, so times by 1 just leaves it the same, and any constant differentiates to 0. So this is the velocity. Okay. It then says that the direction of motion reverses when P is at the point A on the line. So we've got this situation where the object is moving in one direction, like so, and then at some point it changes direction and turns back on itself and starts moving in the other direction. It says that the direction of motion reverses. Now what happens at that point here, at that point A? If you are going in one direction and then you turn back to go to the other direction, you must, at that particular point, have 0 velocity. Okay? Because in this instance, when it's moving to the right, the velocity is positive. And then when it's moving to the left, the velocity is negative. So when it turns around, the velocity is 0. It goes from positive to negative. Okay, so what we could do next is we can, what can we do? Oh, right, we need to find A. So we need to find when the velocity is 0. So 12t squared equals 27. So t squared is equal to 27 over 12. So t squared is equal to 9 over 4. So t is equal to 3 over 2. And it's asking us for the acceleration at that particular point. Well, how do I find the acceleration? Well, I take the velocity and I differentiate it. The velocity we know is this. So if I differentiate that, I get A is equal to 24t. That's it, just 24t, because the constant minus 27, that differentiates to 0. And I'm looking for the acceleration at a particular time, and that's the time when we found just before. So this is going to give me 36, and that's meters per second to the minus 2. Okay. There we go. Right, I'm going to do one more question, guys, and then I'm going to go. I'm going to do the question on the frustum from that previous paper that we were doing. It's the final question, I think, on the paper. Yes, it's this one here. Okay, this is going to be the last one I'm going to do. It's quite a tricky question actually. I'm going to need some space to do it. And it says, basically, just work out the surface area of the frustum. Well, the first thing I'm going to think about is what's the scale factor. We can see the scale factor is 45 over 15, so it's 3. So the whole cone is 3 times bigger in length than the small cone which has been chopped off. Okay. Now, if I'm going to find the surface area, I'm going to need to find the area of one of these triangular faces. Okay, I'm going to have to do that. Now, the best way of doing that is to draw a height line directly down to the midpoint like this. And let's call that distance there h for the perpendicular height of this red triangle. So how am I going to work that distance out? Well, I'm going to use a 3D Pythagoras trick. I'm going to draw a line directly down to the midpoint and then across like this to create a right angle triangle. Okay. So this is 45. And if I do 13, this distance down the bottom will be half of 39, so it'll be 19.5. Okay, great. So that means I can work out h, because it's going to be the square root of 45 squared minus, plus 19.5 squared. Okay, so I could do that on my calculator. And I get 49.0. Okay, so now I can work out the, I'm not going to need this anymore, this green triangle, I'm going to get rid of it. I can work out the area of this whole front face here. Okay, so this pink front face, I can work out its area. And I know that's not what we're going to need straight away, but it's going to help. So this area is going to be a half of the base, which is 39 of that triangle, times by its height, which is 49. Okay. So we could do that calculation. A half times 39 times 49. And we get 955.5. Okay, so now I need to work out the area which is actually chopped off, the area of the smaller shape. There's 2 ways I can do it, and I think the most efficient way is by using the surface, the scale factor. Because if this is the scale factor for length over here, we call that k. So the scale factor for area will be k squared. So it'll be 9. So that means that the blue triangle is going to be 9 times smaller than the larger pink triangle. So I can just divide that by 9. And that gives me 106.2. Okay, so now we can work out the actual part of the shape which we're looking for, this yellow bit. Because the yellow bit is the pink area we worked out minus the blue area. So it's 955.5 minus the blue area. Okay, so we could do 955.5 minus that area, and we get 849.3. Okay, so nearly there, but we're going to have to think, well, how am I going to actually cover all of this shape? All I've got so far is the yellow area. Well, there are 4 identical ones of those. So the total surface area is going to be 4 times by these yellow bits. And I'm going to have to add on the base, which is a square, which is 39 times 39. And I'm going to have to add on the other square on top. Now, what's the other square going to be? Well, again, we're going to use the scale factor. It's going to be 9 times smaller than the base of the big shape. So it's going to be 39 times 39 divided by 9. Okay, so I'm going to take this number and times it by 4. I'm going to add on 39 times 39 because that is going to be the base of the large cone. And I'm going to add on 39, let's do this correctly, 39 times 39 divided by 9 is the smaller one. Okay, great. So I get an answer of 5087. And it says correct the nearest number. So I'm pretty good with that. Okay. Right. Look, I really hope that you enjoyed that. And I wish you all the best in your IGCSE that's coming up. Thanks for tuning in, and yeah, stay subscribed. It really helps out my channel if you could do that, and also if you could share my channel with other people that you know are going to be doing the IGCSE like in coming years. And if you're doing A-level maths, then stick around. I've got loads of stuff on A-level maths on the channel. Okay, everyone, pleasure. Bye for now. Thanks.